Today we're going to talk about graphing square root functions. You can see that I have a function here, f of x equals the square root of x plus 2, and then the plus 1 on the outside. We're going to start with the most basic form of graphing, and that is making a table of x values and y values. So I want you to pause your video and plug in these x values into the function, determine the y values, and then plot your points. When you're done with that, press play for the answers. Notice we're graphing on the real number plane, and we cannot have the square root of a negative number. So if I plug in -3 here, I get the square root of -1, which is undefined in real numbers. So I'm not going to have any values for y until I hit x equals -2, which would cause the radicand here to be 0. And then from there on out, I will have values of y. Okay, so now let's look at this a little bit closer. Let's identify the domain of f of x. Well, the domain are all the possible values of x. So if you notice from your graph, the first time you have an x value is at -2. So the domain is from -2 to positive infinity. And it includes -2. So there's my domain. My range are all the possible values for y. So my first y value from low to high is 1. So my range would be from 1 to positive infinity. The next part asks us to identify the coordinates of the starting point of f of x. So this is my starting point, and my coordinates are -2, +1. Now I want to fill in these values. What is the value of a in f of x equals a times the square root of x minus h plus k? Well, if we look at our function for f, a is the number in front of the square root symbol, and in this case, a is +1. Now, we're going to set x minus h, this part underneath my radicand, equal to 0, and we're going to solve for x. So x plus 2 equals 0. If I solve that, I get x equals -2, and my k value is +1. The next thing I'm going to do is set my radicand greater than or equal to 0. So x plus 2 is greater than or equal to 0, and we're going to solve for x. I get x is greater than or equal to -2. Now, all of this information is meant to tell us something. Notice, -2 is x here. Once I set my radicand equal to 0 and solve for x, I get -2, and my k value is 1. Notice that this x value matches my starting point. This value of k is the same as the y value of my starting point. So the way that I can find the starting point of my graph is by setting the radicand equal to 0 and solving for x, and then recognizing what the value of k is. That would be the starting point. I want you to take note that in this particular case, a is positive. And in a minute, we are going to notice something about how that changes my graph. And then finally, if I set the radicand greater than or equal to 0, what I can find is the domain of my function, because the radicand has to be positive or 0. So x is greater than or equal to -2 matches the domain of my function. Here's a new function. I'd like you to plug in the values for x and solve for h of x and plot the points and draw the curve. Press pause on your video, and when you have your answers, press play again. Here are the answers. I want you to notice that all of these numbers come out to be very nice numbers. 6, 4, 2, 0. I don't have a radical that can't be simplified in one of them. So how can we pick these values so that they come out to look pretty? Well, what we can do is have another row up here that is for x plus 4. If we list our perfect squares as our selection, I would choose 0 here, 1, 4, and 9. Because if I now solve for x, by subtracting 4 from each of these, I get the number that's going to be really nice to plug into my function. So from now on, when these are not provided, you need to start with the radicand, set the perfect squares as the radicand, solve for x, and now you have the values of x that you'll use to plug into your function. Okay, now I'd like you to fill out this chart with all the missing information. Press pause on your video, and when you're ready for the answers, press play again. Okay, here are my answers. My domain goes from -4 to positive infinity. Remember, those are all my possible values for x. My range goes from negative infinity up to 6. Those are all my possible values for y. I'm going to identify the coordinates of my starting point. That's at -4, 6. And the value of a in my function is -2. If I set x minus h equal to 0, I find x is -4. My k value is 6. And then if I set my radicand x minus h greater than or equal to 0 and solve for x, I get x is greater than or equal to -4. Now again, I want you to notice my starting point consists of my x value when I set my radicand equal to 0, so that -4 comes from here. Then my y value is the k value here. My domain matches this. I only have values of x that are possible when my radicand is greater than or equal to 0. So now let's go over what we've discovered. So how do I find the starting point of my square root function of the form f of x equals a times the square root of x minus h plus k? Well, I set my radicand equal to 0 and I solve for x. K is the y value of my vertex. What does the value of a tell us about the direction of the graph? If a is greater than 0, the graph increases or opens up. If a is less than 0, the graph decreases or opens down. How can I go about finding other points to plot? We're going to set x minus h equal to perfect squares. We're going to solve for x and then plug into our function. To find the domain, I'm going to set what's underneath my radical, my radicand, greater than or equal to 0. I'd like to try one more problem that is not in your notes. So I want you to start with x minus 2, which is the radicand, x, and k of x. I want you to choose your x minus 2 values to be the perfect squares, 0, 1, 4, and 9. Solve for x, plug into k, plot your points, draw your curve, and then I want you to identify the domain and also the range of the function. So now press pause on your video, and when you're done, press play again. Here are my answers. So you'll notice I let x minus 2 be all the perfect squares. X, then I solved by adding 2 to each of these values. I plugged my x values into k. To find my y's, I plotted my points and I drew my curve. I knew it was going to open downwards since this was negative, and my starting point was going to be x equals 2, y equals 3. So it started at 2, 3. My domain is 2 to infinity. My range is negative infinity up to 3. So now we can have some idea of how to graph a square root function. I'd like you to try the problems that I put online as your homework, and have a great day.